Okay, hello again. I gave some thought into this and I found that I really shouldn't explain sorry DB that much because the database logic is in continuous change. So probably when this recording is out, most of what I'm saying here got changed. Probably. I'll give some examples on how to trace things so that you can have the tool of how to navigate around the code base rather than actually getting attached into the syntax of this current implementation. So let's start with the message logger. Okay, a simplified interface to Ansari database so that we can log messages, i.e. save messages to the database, without having to share details about the user ID and thread ID. Let's just dive into the methods and see where they are called, and hopefully you get the big picture. So you have here the init function. Okay, we're passing to it the user ID, thread ID, and to WhatsApp, this is just a to say where we will store the info. Because here's the thing. Let me get this out of the way before we start the session. So currently, we have multiple sources, okay, of messages. So we can get messages from the Ansari.chat, the main web application that we have, Ansari.chat, the website. And that website, the flow that it will follow are these tables, the tables below, and the users, messages, feedback, and all of these tables. And then you have these three tables: users, WhatsApp, threads, WhatsApp, message, WhatsApp. And to be honest, this is basically just a duplicate of that main logic here, the threads and messages and users, but for WhatsApp, just to distinguish the two users from each other. And so this isn't really the best way to do things, because in the future we may have more than, like, this is already duplication, but in the future we can have, maybe we decide to store the Discord users in a specific place in the database, and so that's an extra source, and etc, etc. So we'd rather have something like a flag in these tables called source, for example, a column called source, which we can debate the implementation later, but for now maybe it can take something like a string that says Ansari.chat if it's from the web, and can say WhatsApp if it's from WhatsApp, etc. That I think would be better, so that in this column we can just filter by that column, that source column, to get the data that we want. And that's the thing. So probably when this recording is out, we would have implemented that, and then you'd see these tables, these WhatsApp tables, not here anymore. So yeah, so for now, since this is the way that things are for now, then I made here a boolean called to WhatsApp that says, based on where this MessageLogger class is instantiated, this will be true or false. And if it's true, we will use the append message WhatsApp function. If it's false, we'll use the normal append message. And again, very repetitive logic here. You see in the code that we have in Ansari DB that if you see the outline here at the bottom left, that a lot of functions were written before, and then they have their equivalent WhatsApp version. So register function or method, it has a register WhatsApp method. Count exists, same for WhatsApp. Retrieve user info, and then WhatsApp. Create thread, and then for WhatsApp, so on. As you can see, it gets very repetitive, and we need to refactor this. So that's why I decided not to go into the details of the database, because probably a lot of these stuff will change later on. And so this is just a high-level overview of the message logger. Where is it used? Let's see. Where's it called? You can see it's called, for example, in Ansari .py. We define in an instance in Ansari, we pass to it one of its attributes is an instance of a message logger, and it's later used. Let's take this for example. In set message logger, in the set message logger function. So yeah, so I don't know, like, there are two ways to add a message logger to the class, either in the init method above when initializing the instance, or via this method. So anyway it will work. Any of the two ways will work. And then what else do we have? We use, I think if you control F, I don't think you will see, you see it here. So in process message history, if you remember that, log the assistant's response to the user's current thread in database. So once the assistant finally returns a response, if you remember that logic that I will not go through again, where we do the for in each of the chunks of the response of the LLM, and then we add each word to the final string of the final response that the LLM returns after we stream all of its words. And so the final word, like it's the final paragraph, the final returned value by the LLM, we will store that in the database, okay? Just for you to imagine things visually, this function, the .log function, says that I want to store the content of the message, which is word in this case, and say the role who wrote this message, which in this case is assistant, okay, because the LLM. And so in the log here, you will see that the if else that I just explained. And so I just want you to visualize this append message, because append message here, it inserts into the table messages the thread ID, user ID, role, content, tool name, and tool details. What we care about in this case is the role and content, because if you remember the good old paint drawing that I made with the rectangles and all of that, we have the message structure is a list of dictionaries, and each dictionary is a role and the content, okay, role key and the content key. That's the basic structure of the message that we have, either a user message or an assistant message. And if you remember, we said that the tool message has an extra way of being written. We write the tool message in two messages, an internal message and an actual tool message. So that's why we have here the tool details. Tool details, you will see that if we actually follow this along, follow along it here, then follow along in the tool details in the log, you see where it's called multiple parts. So I'm interested in the one where it has tool, okay? So you have here log the tool's response to the user's current thread in the database, tool output string, tool name, tool details. So if you see, tool details here is the two dictionaries that I told you about. Remember in the recording when I told you about that the tool has two dictionaries, a dictionary called internal message and the actual tool message? These are the ones, okay? So I store them like this, okay? This is a dictionary and this is a dictionary, and I store all of that in a bigger dictionary, and I name this the internal message dictionary, and I name that the tool message dictionary, okay? So how do I unwrap this? Okay, let me rephrase the question by giving an introduction first to what I'm trying to say. So you now know how this dictionary, the tool response, gets stored in Ansari database in the messages table, okay? Great. So here's the thing. Now if we go back to the data model, we have the messages here, okay? Here it's like this, okay? And now you can imagine the messages as rows. Okay, let's take a specific thread ID, for example. By the way, a thread ID, again, if I didn't explain it before, is in the front end when the user opens a new chat. It's basically a chat container. That's what we call a thread here in the database, okay? If the user opens a new chat and then he types a message and then Ansari responds, and then he types a message and then Ansari responds, etc., all of these messages are in a thread, okay, or in a chat container. That's what a thread means in the terminologies of this code base. Let's assume the same thread ID here. You can visualize now the message history as a list of dictionaries, okay? And in here in the database, it will be rows, a couple of rows, okay, database rows. And each row has these info. And we care about the info of the role and the content. And we care also about tool details at the end here, if we're going to add the messages from a tool. So you can imagine it like so. Before I show you the function, you can imagine that the way we retrieve a thread history, we retrieve a chat, the message history, list of messages, is that we say, okay, select all the messages related to this thread ID and user ID, okay, return these messages to me, and create dictionaries from that consist of a role, and each role consists, each dictionary consists of a role and content keys, okay? That's a structure that you know about. You can imagine that right now, and I'll show it to you in a second. But just imagine with me now, how will the code write that if you encounter the role tool, then take what's in tool details? Because now the type of message of the user and the assistant is flat. It's just a flat dictionary. It's just a dictionary of role and content keys. But the type of messages from tool is like nested dictionaries. It's a dictionary that has two dictionaries, and I need to unpack these two dictionaries into the message history. So how do we do that? If we go back here, to answer your question, we need to go to which function? Let me see which function here in the Ansari database. I believe it's get all threads, okay? So you'll see here, get all threads, or is it not get all threads? No, get thread LM, I think. Yeah, because get all threads it will just get all the possible chats that the user can open from. So if you remember in the front end, you have the left like sidebar where you say you have a chat at date yesterday and then another chat at whatever. So all of these are the entire thread that you have. So this function will get you all the threads related to you, to this user, okay? So that's the use of this function. But no, the function that I care about, I think, is get thread LLM. Yeah, retrieve all the messages in a thread, in a single thread. We get all the messages. This is designed for feeding to an LLM since it includes two return values. So let's go by this function because it's an important one. We select the role and content and tool details from messages. So you remember, the role and content is for the basic type of message. The message was just a dictionary consisting of the two keys. Okay, so this is obvious. and we get the tool details. Let's see how we use this specific column, okay? So we run the query, okay? And we also select the name from threads or ID and user ID. That's another command that we run, okay? And so this command will run and give us this result, and this second command will run and give us this result, okay? We will say first if there's no thread, if no thread returned, then incorrect user ID or thread ID to retrieve the chat history for. If not, we'll do the conversion, and this is the part that I care about. We get the thread name, okay, which appears in the front end in the left sidebar. Okay, so we have this convert message LLM, and this is a function that somehow gives us the required dictionary or dictionaries and extends the messages list with them, okay? So you can imagine the final outcome of this is a list of dictionaries, and that's what the model expects. That's the message history that I kept telling you about. Consists of a list of dictionaries. Each dictionary is a message. So this is what we want. Okay, what happens here? Let's see. We say the following. If the message has a length of 3 and message 2 exists and the third element is not none. So what do I mean by this? This part, if we go back here in the message itself, so the message itself is an iterable, either like a tuple of whatever, because database row returns tuple of strings. So if we go back here in database row, we're saying the database row in result, which comes from this part, which is from this XMD, which is this. We're saying if the length is 3, like the length of the current row is 3, which should be the case because we're selecting 3 columns, okay? And that's the important part. The message to the third element exists. This means it's a non-falsy value. Like it's not none, it's not false, it's not an empty string, whatever. And this third element is the tool details column, okay? Because 1, 2, 3, this is the third element, okay? If the tool details exists, okay, if it's not none in the current row, then we get it here, and then we have the 2 dictionaries that we want. If you remember, I told you about the structure that we have in tool details. When I stored it in the database, I stored it like this: internal message and tool messages. So we're extracting them back from these same keys, okay? So here we get the internal message, and here we get the tool message. These 2 variables are these 2 variables, okay? And we now get these 2 messages in a dictionary, dictionaries, and I put them in a list, and I return that list, okay? Okay, if not, like if this is not the case, if there is no tool details, in other words, if the message is from a user or an assistant, not from a tool, then we return a list which consists of only 1 dictionary. One might ask, why do we return a list even though this is just a single dictionary? Because here, if you go back to the logic, where is it? In extend, that this is an extend. What does an extend mean? Extend means that we take the list or iterable here and we extend it. We take each of its elements and put it in the original object that we want to add it in. So let me tell you an example, a very quick example for this, if you can't visualize this. It's also a cool thing to do, by the way. Whenever you're confused about Python syntax or whatever, you can just run up Python in a terminal and try it out together just to see what works and what doesn't work. So if we say A is, let me see, it's 1 and 2, just a list of integers, and then 3, 4, okay? So this is A, and then you have B, okay, equal an empty list. Now if I say B dot extend A, okay, what do we get? Okay, let's do actually the normal append that we are used to. What do I want to say here? No, I want to imitate the for loop above. So if I say for element in A, and then I say B dot append element, okay, we get, okay, and I say B, we get 1, 2, and 3, and 4. So what happens here? The first element was this 1 and 2, so we appended 1 and 2 to B, and then the second element was 3 and 4, so we appended 3 and this list to B. So now B is similar to A, okay? But what will happen if I do the same thing? If I do the same thing, and I define B in response, and I start the element, and I say here extend, okay? What will happen here when I say B, say B, is, see what happened here? Let me explain here. 1, 2, 3, 4. What happened is that in the first one, we have element equal to the list of 1, 2. We extended, i.e. we extracted, like we unpacked the iterable that is in element right now is a list. So this is an iterable. It's an iterable type, something that we can iterate on. So we extended that, to its inner elements, and then we added each of these elements to B. So that's why in this for loop iteration, we added 1 and 2. And then in the next iteration, we extracted the 3 and 4 from here and added them individually into B. So we get this, okay? So this is a summary of what's happening. Sorry, I took so much time to explain this, but hopefully you can visualize it now. And I wanted to do this explicitly because this way of thinking will help you out. Of just opening up the terminal, trying something really quick to validate your thinking. Your way of thinking. Another easy way is to just create a Python file, .ipynb file, and try what I did in the terminal here. And actually, I'm sorry, I know that I'm going off topic a lot here, but because these are useful tips in my opinion. I believe in Python, in Visual Studio Code, if you do something like this, okay, this will behave like a cell, like a Jupyter notebook. So if we said here what we want, the same example that I wrote in the terminal, but let me write a simpler one, just hello, okay, without even the word, and then we run it, see what happens? It already tries to run Python in this part only. It needs to install an IPY kernel. So this is the only restraint here. I can say select another Python environment which has this kernel. Okay, so in here I may select maybe Miniconda, the normal Miniconda. I think this has a notebook installed, like a kernel installed, so I can maybe use that to run. No, it doesn't have it as well. Okay, so this will, to be honest, this tip is very useful if you have in the current environment IPY kernel installed. I'm not going to install it for the sake of time, and because the internet here is awesome. But if you have it, then it will help you out. You can simulate what you're doing internally here as well, and you can change these as notebook cells instead of creating a .ipynb file. So hopefully this tip is useful for you. I just wish I could have actually made this example to the end. I'm not going to install IPY kernel. Hopefully you understand now how we get the messages back from the database as a message history, and then we feed it back to the LLM, okay? And again, for you to visualize this, when I said the get thread LLM, this one, where do we call this? We call this here in the add message in the main API. We say that this is a history with the get thread LLM, so this returns a list of dictionaries, okay? And this is a history itself. Okay, it returns okay, wait. In order for me to be concise, it returns a dictionary of thread name, just a thread name that appears at the front end, and the messages, and this messages is a list of dictionaries. This is the actual history, okay? So this is just me being very concise. So here in history, we use the messages here, this one, if you see this, we append to it the user message, the final user message, and so the history is now complete with the latest message that the user just asked for in the front end, and we pass that entire history to the presenter complete. The presenter complete, if you remember, instantiates the Ansari agent, and the Ansari agent now has the entire message history, so that's why it replaces its old message history with a new one. And we set up here the MessageLogger, which I explained is responsible to store the remaining messages that Ansari sends back to the database. So hopefully you can see the entire loop like coming together now. If something doesn't add up, you can trace the code again yourself, but it's not really that, okay, it's complicated, but it's not that complicated. Okay, this was the main thing that I wanted to explain with Ansari database, because I think this logic will not change that much, I hope. Other parts here that will come and go, okay? Like the way we write these queries, or what we're using, maybe even the database, the PostgreSQL, maybe that will change as well, I'm not sure yet. So yeah, this is what's happening here. I think that's all for Ansari database that I will explain. And yeah, when you see this again, you'll probably not see the to WhatsApp, you'll probably see like here, maybe like source or something, and that will be a string instead of a boolean, and based on that string, we will run specific queries for specific tables, or the specific table but on the source column, and we will change. That's why I didn't explain in depth what the queries itself does, okay? I just give an example of the getThread LLM for you to visualize how we return the message history. One final thing I wanted to discuss about, actually, let me just write something real quick. Okay, okay, something completely unrelated to Ansari now, but it will really help you out, so I thought I'd tell you about this nonetheless. Is GitHub Student Developer Pack. So if you're a student, then you really benefit from this. And this is not advertising, this is not anything, this is just literally something that benefited me so much that I thought that I'll tell you about this. In here, whenever I need something, I just go to the chat here and ask questions, okay? And so this is very helpful. I can change the model that I want to use here from a list of models that's available to you. All of these are available to use as long as and as much as you want if you're in the GitHub student pack, okay? and it's very great, to be honest. You can select here stuff and it will appear what the context you want is. You can write here like symbols specifying the exact file. So if I say Ansari DB, it will use, or here Ansari DB class, it will use the entire class as reference before answering my question. It's very great, and there is a lot of documentation for it in Visual Studio Code itself. I love this, to be honest. Extension, it helped me out so much, and it continues writing for me. For example, and sometimes it deduces what I want to do and do a similar like, okay, let me give an example. If I see a WhatsApp function here, if I remember correctly, when I saw register here and I just did a diff and register WhatsApp, it auto completed with the implementation based on what was above. Okay, but I'm not sure if it will work. Yeah, not sure if it will work now or not, because again, the internet is not the best, and so it just continues implementations for me, and so that's very useful, as you see the autocomplete that I just made. And it does more than that, but yeah, see, like here, it implicitly took what was said before and provided me a function similar to that, but for storing in WhatsApp. Obviously, it can hallucinate here, so you have to double check it, but it's very useful. The inline chat is useful. The chat at the left here is useful. I love this. You should try, if you can, sign up in the student pack if you're still in a university or school that has a way of verification and in email related to it or whatever. You can sign up here. It offers a lot of tools in all offers here. One of the most important is the GitHub Copilot that I just showed you, but there are other important stuff as well. You can get a free domain for a year. You get stuff on Microsoft Azure with like $100 credit. It's amazing, to be honest. A lot of services that become free or free for a certain time for you, and it's very great. So that's one last thing I wanted to talk about. And one of the great features is GitLens. GitLens here, if you know this, is a very great extension to see details about the GitHub and the commit graph and all of that. What I love about it the most is an experimental was an experimental feature, is now I think became a stable feature for it, stating what you can write in the commit message that you do before pushing into GitHub. So here, for example, I made this change to do now, as I removed this to do, and this import was added at the top. So if I go here, and then actually let me show you something first. If I go to settings, and I type GitLens AI commit message, for example, commit message, I see here generate commit messages enabled. This is a preview, so this is not established yet completely stably, but I have this enabled. And then we say here the custom instructions. So I say use a conventional commit guideline, as in here, to format your response, and in the details section try to be more verbose on what has been changed. So this is a custom message that I wrote, and the link that I provided is a link on how to properly write commit messages, okay, with examples. And I think it's better because I don't think it accesses the web, so I think it's better for me to take these as examples and put it here. Anyways, when I set these two stuff up in the settings and I come back here, okay, I remove this, okay, and I go here. So this is the current change that happened, okay, these two changes only. So if I were to commit this, and I go here and say Control-Shift-P, and I say GitLens generate commit message, okay, it will give you a prompt to do it via ChatGPT or whatever. You say accept and trust it and whatever, and it gives you this. It removes unused to do comment and adds test and print statements. Remove an outdated to do comment from the file, add a test to print statement at the end of the file for debugging purposes. I'm actually not sure if I did this or not. Let me see. No, I only did the to do and the UID. There is no other changes that was made here. So actually this was hallucinated, okay, but this was not. It's useful for you to but it actually is the first time that hallucinated with me. Like normally when I do a couple of stuff, it adds them all here together in bullet points. This is the first time it did this, but as in any LLM, you have to double check it doesn't hallucinate. And it's very just a quick way to write commit messages instead of seeing the changes one by one. So I recommend this as well. That was all. Sorry, I got sidetracked here from talking about Ansari, but these stuff all helped me out so much, and I thought it was worth your time. Hopefully you gained something useful from all of these, all of this time that I've been recording. And if you have any doubts or questions, you know the maintainers of this repo, so ask away. And I'll see you soon, inshallah. Bye, boys.